welcome to Linkswood in Fife. This is our drone training facility. We do a bit of testing here, we do training, we do all sorts. Today we've got a special surprise for you. We've got a new payload. So the brand is Share UAV and the model is the 102S. I'll take you down to the drone, we'll have a wee look on it. It's mounted on the DJI M300 here. Compatibility wise, don't be too worried about that with this brand. So it actually goes on the M600, the 210, we can get it on VTOLs. So this brand, Share UAV, one of the top suppliers for oblique lenses in Asia, they will work with the customer. So they'll work with the supplier, which is me, and in turn that'll help you. So down to the payload, your first vision of it is the beautiful red colour. Distinctive red, we like this with the Share branding along the front. This is a metallic finish on aircraft grade aluminium, so it's very light, the payload. This payload weighs 650 grams. Now consider it's got 5 lenses, that is lighter than the Zenmuse P1. Now weight, in terms of weight on the payload of these aircrafts, the lighter the payload, the less wear you're going to get on the motors, and in turn you're going to get more flight time out of it. So weight is a huge concern when you're building payloads. So we'll just go over some of the key points to the payloads. It's got 120 combined megapixels, so that is split over 5 lenses. You will see 24 megapixels per lens, which is it's good. It's ahead of, say, the Phantom 4 RTK. What also you'll find is, we'll talk about the position of the 5 lenses. So this is key, there's one point in 90-degree angles down and the rest are at 45-degree off. At every capture where we'd normally have a single shutter, we've got 5 shutters going off, giving us different angles. This will improve, it'll lower capture time and it'll improve the quality of each image because we're getting that kind of side-on view at every point as well. We're looking forward to testing this platform. So we're about to set the, you can see the Share 102S on the drone. We've got some equipment here. We're about to do the planning on just the DJI remote in the field, and we'll do some tests here at our site and we'll show you the results soon. So we're going to start some flight planning today. You can see I've got my little desk set up here. This is known as a field desk at Edinburgh Drone Company. Right, so we're going to start with the flight planning. I'm just going to record my screen in front of me so you can follow what we're doing on either the camera here or when it comes in, and we're recording on the screen. Right, so we'll just go back to the start. Pilot 2 is installed on our M300, so we're just clicking into the Pilot 2 system. You can see the health management system and all your usual data there. We're interested in an autonomous flight mission, so it's a flight route. Click the flight route. Now we are going to create a new route in the field. So you've got 2 choices. You can either import a KMZ file, which will allow you to import your pre-planned flight route. We like to do it in the field so you can see the actual hazards around you and you can see what, like, certain heights, and you just get an overall idea of the area a bit better rather than looking at Google Maps and pre-planning it. So we're going to click the create route. Now you'll see, although we are about to do an oblique image, we still choose the mapping option. It's in the payload that it will transfer it into an oblique image. All we have to do is set it on a mapping mission. So we're hitting mapping. Right, so you can see if you're following on, I'm going to zoom out a little bit and get our training facility land outlined. There we go, tap that and then I can change it slightly. Right, name your mapping mission. Test 4 for us. Select your camera. Now I'm just going to move the little screen recording bit there. Custom camera. You will see a 102S, but there's no way to check the settings on that. So if you go into custom camera, you can see we've already installed the 102S Pro that we have. I'm just going to click the little settings tab and it shows you all our settings. So you can see there the width and the height of the photo size, the sensor size, make sure your focal length is right, and minimal interval time. So we're going to select that camera. Now you can see our GSD is 1.57 pixel. We're going to bring that down a little bit by altering our height. So we are quite happy to fly over this land at about 50 meters. GSD, so that's even, I would say, quite low still, so we can maybe go 60. Right, there we go, bang on about 1 centimetre to 1 pixel where we like it. Speed, everything else is good. You need to go into advanced settings here. I'm quite happy with all the overlaps. You want to change the timed interval to distance, so the photo mode is very important. Distance interval shot. Right, so you can see our flight mission here. The estimated time is 21 minutes odd. There's 34 waypoints, roughly 1,000 photos, and we've got a huge area we're mapping there. Now this is our land up in Linkswood near Lookers and Fife. We want to try and get an idea of the whole site today. So we've got the oblique camera, we might as well do the long mission. It'll be interesting to see 21 minutes is a single flight path around this site. We could not get three-dimensional data by doing this normally, so you would be 4 or 5 times the length of this to capture this with a P1. That's us just now, Jack. We're ready to take off. So that's the drone back from its flight mission. All the data is captured on the device. There's an internal hard drive in the Share UAV payload, so we just need to take that across to the computer. The first stage is running it through Share UAV software, and then we're going to use DJI Terra to keep in with the brand and the drone. We're going to use DJI Terra to reconstruct the 2D and 3D software. We'll see you in the office. So we're back at the office now trying to take the data off the new Share 102S. It's as simple as plugging in the provided USB to Type-C cable, opening the software, and we're straight into it. First task you'll see is just change the language so it's a little bit more, a little easier to understand. It's identified the attached payload that we have plugged in, so all we have to do is tell it what drone we want the pictures prepared for. We were running the DJI M300, simple as that. Okay, and off we go. The Share UAV website can be looked at for any help if you ever need that. Straight into the software, you'll see the 3 flights that we've run. The one we're interested in is the bottom one at 102. We're going to copy the files. You'll see our big long flight path there at the bottom. At this stage, all you've got to do is select the folder you want the data to be saved in. So we're just going to save it in a test4 file. Select this file location. It's up to you where you save this. Could be on the cloud, could be on your computer. At that stage, just press the start copy and you are off. So after the Share software has prepared the files and images for going into your reconstruction software of choice, you'll see if you're following on screen, it gives you a back, down, front, left, right. Don't worry about any of the other files, but this is now test 4, this whole 0809 is ready to go into the reconstruction software. So we're going to use DJI Terra for our reconstruction. So we're just going to go, if you're following on the screen, new mission, visible light. We're going to stick with test 4. Right, we're going to source our files. There's test 4. That's the whole file. So just tap on that, select folder. Now, there's 4,805 photos in this folder, so it's going to take a wee while to go in. We'll cut back to when the photos have all uploaded into Terra. So as you can see from the screen, the 4,805 photos have been put in. We'll just quickly click into this to see how they've been ordered in back, down, front, left, right order. This is preparing it for how it's going to try and mesh all the data together. At this stage, choose 2D mapping, set your resolution requirements, scroll down, set your 3D mapping requirements, select your output files, and then just click Start Reconstruction. So that's the 4,800 photos all on the DJI Terra reconstruction software. It's all gone in, the 2D map and the 3D map's now ready to view. Time scales for DJI Terra, the 2D map to get through 4,800 photos was about 3 to 4 hours. The 3D reconstruction was about double that, so about 8 hours. The times will vary depending on what reconstruction software you're using. Right, if you're following on the screen, you'll see each one of the white dots indicates where 5 photos were taken at each time. I'll just get rid of that so we can view our data. And here's our site. This is our drone training facility. We are based down here, but for interest, I just want to show you the capability of the reconstruction software and how we can, and what we use it for and how we can measure. So this little tool here is the measuring tool. We've got a linear measuring tool, or we've got a volume area measuring tool. We're based on an ex-MOD site. So this is an old fuel tank for the fighter jets. So we're going to see roughly how much of the fuel tank is above ground level. That's us. A wee right click and it shows you the protected volume area. Another good one, if we click off of that, we'll go to linear distance. Let me just zoom in on our... So this is the old pump house here. What's it useful for? This is good for roofers, construction workers. If we take a point here, take a point there. If we right click at that stage, roughly 16 meters. And then we can carry on down to here and get... There we go. Another quick one. Volume of this section, take the 4 points. There you go. Right, so we're going to click across to the 3D reconstruction now. Click the 3D part of it. Now, interestingly, we were just looking at this, comparing the 3D and 2D data. You actually get a bit more overspill in the 3D data because we can capture further out with the angles of the camera pointing at 45 degrees out. We get a bit more overspill, so that's quite rare in the drone world. Normally we have to cover more ground to capture the data. With this payload you can actually cover less ground and still catch the data. For example, let's have a look. We have a BMX track over the back of our land that we're allowed permission to fly over. Now we didn't fly over it on this day, but it has captured that quite nicely. Right, as you'll see, which is quite unusual, we've captured a very nice side detail of some lovely graffiti, to be honest, but it's actually quite good to show the purpose of what we're kind of doing here. Look at the detail there. So we're back in the 3D rendering software here, and I want to show you our pump house just to kind of discuss some of the GSD and accuracy questions we've had about this payload. So as you see when we're orbiting this pump house here, I'm zooming in. Unbelievable detail captured here. The GSD is 1 centimetre to 1 pixel. Now our flight mission was flown at 60 metres. You can fly well up to, advised is approximately 100 metres. We quite like to be lower, you just capture a bit more detail, but each job's different. So after reviewing the 2D and 3D data there, I hope you've got a feel for the Share UAV brand. They are the Oblique camera leader in Asia, so it's good to see this camera here in the UK. Don't hesitate to ask us any questions. We'll be making a few more videos on the Share UAV range, so watch out for them and we'll see you on the next one.